A structural memory is embedded in a simple circle and is released when the circles of the same size self-organize. The four shapes of the 60-degree family are the first information remembered: the 90-degree triangle, the 60-degree triangle, the 60-degree diamond, and the 60-degree hexagon. Next, we find circles can self-organize to define a size relativity field. At the center of this order is our U-Me ball with a radius of BB equals 2 centimeters. This is our all-purpose scale number that all other structures will be relative to. Four 6BB circles can self-organize to construct the minimum expression of a sphere. The 12 white locations in common where the circles meet define the 12 outside corners of the 14-sided VE, vector equilibrium. The VE has 8 60-degree triangles and 6 squares. I defined the 6BB length as the maximum reach of our U-Me ball center. Larger numbers will be multiple of 12 centimeters. 3 circles on the level playing field define our hexagonal equator that divides the VE in half. 90 degrees to the plane of our equator is an axis of spin that all other structures will be relative to. We now have a solid foundation to compare and contrast new geometrical systems, polyhedra. The self-organization of spheres of the same size is one of the most fundamental structural and numerical constants found in nature. Using Buckminster-Fuller's theory, we define 3 layers as the initial cycle of spherical growth. We begin by asking what is the minimum number of spheres to build a continuous layer around our U-Me ball. The answer will always be 12. Measuring center to center, this VE has an edge of 2BB equals 4 centimeters. The closest packing of same-size spheres not only defines this initial layered order, but it constructs a communication network connecting any center to its outside limits. There are 50 directions in this type of network. There are 4 fundamental locations in common that this network connects: the center, the outside corners and the lines of communication between them, the edges, symmetric division of the outside edge, and the center of the outside shapes. All order radiates out from the center. The 12 white directions pass through the center of the spheres to define the VE's outside corners. The 24 yellow directions pass through where the spheres touch to the midpoints of the outside edges. The 8 blue directions pass through the 3-sphere gap to the center of the triangles, and the 6 green directions pass through the 4-sphere gap to the center of the squares. The second layer of closest packed spheres needs 42 to surround the 12 around the 1. The 50 directions organize this layer. The third layer needs 92 spheres around the 42, around the 12, around the 1. This is the first cycle of growth. 146 spheres around our central sphere. So one sphere can hold all of this information embedded in its structure. A sphere can be defined using just 4 circles in 60-degree orientation with each other. We define the first circle's radius as an all-purpose scale number. One circle holds all of this structural memory. The next video introduces the outside containment field around all of this information, the 12-sided rhombic dodecahedron. In essence, it's a 12-sided sphere that has connections to spheres in many different ways, as well as the closest packing.